Okay, not to waste anyone's time and to get into the fun stuff, let's just kick things off. We only have 1 hour. So, hello and welcome to today's webinar on the developing market for retrofit panelization. Today's webinar is jointly hosted by ZEBx of the Zero Emissions Innovation Center, ENBIX of Alberta Eco Trust, and the Atmospheric Fund, commonly known as TAF. My name is Natalie Douglas. If I haven't had the pleasure of meeting you folks, I'm here today as the program manager of ZEBx. So that's the BC-based Zero Emissions Innovation Center, otherwise known as ZEEC. We do love our acronyms. As to why we're jointly hosting this webinar, one reason is that we're all part of the Low Carbon Cities Network, so LC3. This network, often called another acronym, because why not? It's a federally endowed network of 7 locally governed urban climate centers across Canada, whose mission is to help cities reach their greenhouse gas emission reduction goals by supporting, de-risking, demonstrating, and scaling up local low-carbon solutions that also help improve public health and local economies and a series of other co-benefits. And although we're all about encouraging place-based solutions where it makes sense, reducing redundancies where possible is absolutely also a favorite. So for today's topic on prefabricated panelization systems, we're hoping to stimulate a cross-Canada conversation on building up this market by hearing from TAF and ERA architects on their efforts in Ontario. So near the end of the hour, we're going to transition into a short little panel discussion where if you guys have questions, just throw them in the chat and we'll bring those out and have a discussion after the hour. If you guys are extra keen, these speakers were lovely enough to offer their time. So if you have, more specific questions, it will go past the hour for another 15 or 20 minutes. So if you're extra excited, we have created space for that. Now, before we begin, I'd first like to take a moment just to acknowledge that we're joining from many places across Canada that are the traditional and often unceded territories of Indigenous nations and peoples. All participating organizations in LC3 recognize that the work of building low-carbon resilient cities is deeply connected to reconciliation, to restoring relationships with Indigenous people, honoring their stewardship of the land, and ensuring that climate solutions are inclusive, just, and integrate Indigenous knowledge and leadership. So with that, I'm so glad to pass things over to our speakers today, Keith, Graeme, Yael, and Natasha. Over to you all. Keith will kick things off first. Over to you, Keith.
And sorry, Natalie, before we move it over to Keith, I'm just going to run a really quick poll just to see where everybody is joining us from today, as well as what your field of work relates to. Do you work mostly with commercial or residential buildings? And just give us some insights as to the awareness of this topic as well, please. We'll leave this up for 1 minute.
Okay, great. And I will share my slides. Okay. So thank you. Hello, I'm Keith Burrows. I'm the Director of Low Carbon Buildings for the Atmospheric Fund. I'm really happy to be participating in this panelization webinar as it's a topic that I'm really excited about and something we've been working on for quite a few years now. Let's see. All right. If you're not familiar with the Atmospheric Fund, or TAF as we're known, we're a nonprofit. We're focused on identifying climate solutions and helping to scale them up for broader adoption. We work throughout the Greater Toronto and Hamilton region, and our mandate is climate change mitigation. We do that through policy advocacy, investing in companies and projects that are focused on decarbonization, providing grants to nonprofits and municipalities, and running our own programs. Oh, there is the poll results. One of our largest programs is the Retrofit Accelerator, which we launched 4 years ago now. Okay. I'm not going to go into a great detail on what we're doing with the accelerator, but at a high level, we're facilitating deep retrofits and supporting owners of multi-residential buildings through the deep retrofit process by providing hands-on support, kind of like an owner's representative. We work to reduce the risk and financial and technical complexity of these projects from the perspective of the building owner. We also, in addition to the work we're doing on specific retrofit projects, will also undertake very specific market development activities when we see that there's a particular need or there's a benefit to the work that we're doing. And one example of this is our initiative that we currently have underway to pre-qualify suppliers of prefabricated overcladding panels for retrofit projects in the Greater Toronto and Hamilton area. So realistically, not every building is going to get the Passive House super insulated overcladding treatment by 2040 or even 2050. It's just not possible at the pace of retrofits today. And overcladding really isn't necessary or viable for all buildings, but there are many buildings where it makes a lot of sense, especially older buildings that have little insulation. The cladding is in need of repair or replacement. These are perfect candidates for overcladding retrofits. And prefabrication offers the promise of better performance, reduced timelines, and lower costs. As the market for prefabricated panels matures, we expect cost and implementation timelines to come down. But from what we've seen on 2 projects that we're working on right now, both of these will be discussed in this webinar today. Prefabricated panel costs are cost competitive with site-built overcladding solutions, but they can be implemented faster. So prefabrication already makes sense today, and the case will just get stronger as the market matures. And one thing that there's very little question on is that prefabricated panels have the potential to far exceed site-built overcladding solutions in terms of quality. Panels can be built in a climate-controlled environment that's optimized for panel construction. And prefabricating panels in a climate-controlled environment also offers opportunities for QA, testing, and rework before the panel even gets to the site. And because we see real promise in prefabrication for deep retrofits, we decided to pre-qualify suppliers who are working in the Greater Toronto Hamilton area for retrofit projects. And we started this initiative probably now 3 years ago now. And the goals that we had established for this pre-qualification were to help the panel suppliers see that there's demand for retrofit panels today, and that that demand we expect is only going to grow. We wanted to understand who the suppliers were in the market today, and we wanted to encourage those that were focused on new construction to consider getting into the retrofit space. And we wanted to very practically create a public roster of pre-qualified panel suppliers that anyone could use. It was something that we could put on our website, our building owner partners could use it, and we could also use it for our own retrofit projects. And we assembled a pretty amazing team to develop the approach and conduct the evaluation. This team included members of Toronto Community Housing, Durham Regional Local Housing Corporation, University of Toronto, and WSP, who were awarded the work through an RFP that we had issued for building science support, and they're still providing us support on this initiative today. So I think it took about a year for us to finalize and nail down our approach to the pre-qualification. After a lot of discussion, the team agreed that we were only going to do a technical evaluation of the panels. This allowed us to focus on the characteristics of the panels that could be fairly evaluated without being associated with a specific project. Building owners can then issue project-specific RFPs to the suppliers on the rosters, and the RFPs would cover owner and project-specific requirements that can't easily be assessed in a pre-qualification. Some of these might include costs, insurance requirements, and labor requirements. And then we ultimately decided that we needed 2 separate rosters of panels, one for pre-assembled panels that would typically be used on low-rise projects, and another roster for non-combustible pre-engineered panels that would be typically used for larger Part 3 buildings. And having 2 rosters allowed us to have 2 sets of technical requirements, slightly different from each other, and it allows building owners to pull from the roster that's most appropriate for their projects. So in the first round of pre-qualification, which was done last year, we pre-qualified 3 panels. We had 3 submissions and 3 successful pre-qualifications. One was a pre-engineered panel by Flynn, and we had 2 pre-assembled panels from Quantum Passive House. And of course, we were hoping for a stronger response, something greater than 3. But part of the reason we're doing this work is we knew that there really wasn't much of a market for retrofit panels at the time, and we expected that eventually we would see more suppliers respond as we continue to open up the rosters for pre-qualification. And when you're doing market development activities like this, you don't always get direct or timely feedback on the work you're doing. You don't necessarily see the impact that your work is having. We were really excited at the Retrofit Canada conference this summer. Quantum Passive House did a presentation. We had pre-qualified their panels last year. And during their presentation, they highlighted the role that TAF's pre-qualification materials had in convincing them to get into the retrofit space. They reflected in their presentation on how well the pre-qualification materials and the requirements were put together, and that really helped them establish a path for developing a retrofit panel. And we were really gratified and exciting to see that, our work was having exactly the impact that we were hoping for. Really exciting. So we're now in the middle of evaluations on our second year of pre-qualifications. And I'm happy to report we have 6 suppliers who've submitted panels for pre-qualification, 3 pre-assembled panels and 3 pre-manufactured panels. So hopefully, if all goes well, by the end of the year, we'll have 9 panels pre-qualified, which is certainly more than we expected to have at this time. It's a really good sign that there's some excitement out there. And we're seeing demand for prefabricated overcladding today in some of the projects we're working on. We have right now 6 projects that we're supporting that covers about 500 homes. That's including panelization. We have a 16-unit building in construction that my colleague Natasha will talk about. We have a 22-story tower that Graeme and Yale will discuss, where construction is just getting underway. We have 4 different townhouse complexes that are all in concept design, and those townhouse complexes are all looking to do prefabricated panels as well. So what did we learn from 2 rounds of pre-qualification? We confirmed that there's demand for panels today from building owners, but the supply of panels in the market is limited. This really isn't a surprise, but was confirmed from our work. The demand that we were seeing is largely driven by some really great retrofit funding programs that are in place. So it'll be interesting to see what happens if those fundings change or go away over time. Having participation from building owners in this process was really key. They have a lot of experience with overcladding projects in their portfolio. We were able to understand their procurement requirements, so we could make sure the process that we followed would meet their requirements and they would be able to use the roster. Was extremely important to us. And they also had projects in the works that were considering prefabrication. So it was just really a really nice synergy, and it was super valuable to have them as part of the team. A lot of the other initiatives that have already occurred in this space are either focused on large buildings or small buildings. Because this is a market development activity for us, and we work on large and small buildings, we really wanted to make sure that both were covered. So creating 2 separate rosters that address small and large buildings was really really important to us, and something that was not, it wasn't something that we were thinking about when we first started this endeavor. And then it's kind of simple now. It seems very obvious, but originally we were thinking that the evaluation would be very broad. But really what we found is that it's just important to focus on the technical requirements and do a technical evaluation initially. And this would provide the most flexibility for building owners going forward. Okay, thank you very much. I'll hand it over to my colleague Natasha to discuss a panelized retrofit that's just nearing the end of construction. Natasha.
All right, thank you, Keith. Hi everyone, my name is Natasha. I am an accelerator. I'm an analyst on the Retrofit Accelerator team at TAF, and today I would like to share a case study for a panelized retrofit project, which is 575 Danforth, a community housing building in Scarborough. The prefabricated panels were one of many measures implemented as part of a deep energy retrofit at the site. So this building is owned by Toronto Community Housing. It's a seniors apartment building built in 1958 with 16 units, and they are targeting ENBIX certification. The measures should result in 60% energy savings and 80% emissions reductions. Construction began in January of 2024, and it's expected to wrap up in a couple of months. And the building did remain occupied throughout the entire construction period. So some of the key measures include installing a geothermal VRF heat pump, which replaced the atmospheric gas boiler at the building. It also provides now central cooling to the entire building, which didn't exist before. The domestic hot water electric tank heaters were replaced by a water source heat pump tied to the geothermal loop, increasing efficiency by a factor of 4. The original building had no ventilation, so we installed in-suite ERVs to provide that. The original roof is a built-up roof, so we installed panels with an RSI of 10 on top of the original roof. The original walls were brick veneer over masonry block, and we also installed prefab panels over the walls with an RSI of 7.94. The original windows and doors were double pane aluminum windows and single pane doors, and they've all been replaced with wood framed aluminum clad Passive House certified windows and doors. The original T8 fluorescent light fixtures were replaced with LEDs, and a VAS was installed, which integrates all the mechanical equipment and the thermostats in each unit. So these panels that we installed were manufactured by Simple Life Homes. They are wood framed panels that can use different insulation types and cladding based on the requirements of the project. In this case, TCH requested mineral wool insulation and pre-finished standing seam metal cladding. The control layers that are integrated into the panel include a drained and ventilated rain screen, fully adhered membrane with continuous sealing, a climate-specific smart barrier, and continuous exterior insulation to minimize thermal bridging. There's also pre-engineered penetrations and sleeves, and factory integrated quality assurance checks for joints and transitions. 2 types of wall panels were installed in this case, ranging in thickness from 319 to 342 millimeters. So the process of installing these panels started with taking LiDAR scans and physical measurements of the building. From there, shop drawings were developed, which went through multiple rounds of iterations by the engineer and architect. And once final shop drawings were developed, they were manufactured in factory in Brighton, Ontario. Once delivered, they were able to be installed in 10 days. And the scope was originally to have the windows and cladding integrated with the panels, but they were unfortunately installed separately due to long lead times. Some modifications also had to be made to the panels and the cladding on site, like removing the window seal, for example, on the existing windows to allow for adequate spacing. So since this was the first prefabricated retrofit project for many of our project partners, I spoke with the building owner, general contractor, and the panel manufacturer to gather some lessons learned. And the ones that came up time and time again were prioritizing good communication and coordination, the importance of LiDAR scans and accurate data sets, that new processes inevitably have friction, and to consider the appropriate applications for prefab. So every project, of course, requires good communication and collaboration, but it's especially important when it's a highly detailed and sequenced process like this. In this case, they used a DC-DC2 contract, but the manufacturer and TAF really highly recommends using more collaborative contracting models like construction management or integrated project delivery. These models bring parties together in the design phase, which really results in better communication and coordination of responsibility from the beginning. It ensures that everyone understands the project requirements and what information will be available to them and when, and prevents delays with decision-making processes and minimizes the number of iterations required. Ideally, having a BIM coordinator would also be helpful for coordinating all the building information required to build an accurate model. Related to this, the importance of LiDAR scans and data sets cannot be understated. The level of detail required to develop the shop drawings in this case was not scoped into the original LiDAR scan requirements. So they were not really useful for building a model and developing shop drawings. They had to rely heavily on the physical measurements taken on site. The manufacturer should really be provided with detailed scans, which can then be validated with tape measurements and photogrammetry, ideally all pulled together by a BIM coordinator. The scans should be done after all exterior demolition and prep work is complete. And this really needs to be built into the project timeline because it can be a lengthy process in itself. This accurate early stage information is critical for preventing delays, preventing the need for on-site modifications, and staying within the budget. In this case, lots of tolerance was built in for the panels due to the lack of detail in the LiDAR scans, so they were able to be successfully installed, even though they didn't match exactly the as-built conditions. And of course, with any new process, there's bound to be friction. And since retrofit panelization is a relatively unconventional process, it's important to make sure there's buy-in from all project parties from the very beginning. The timing of work is also critical, especially if the cladding is shipped separately. The panels themselves can be, when exposed to UV, can degrade over time. So timing when the cladding is going on is also important. And it is a learning curve for contractors, manufacturers, and building owners who haven't been part of a panelized retrofit project in the past. From the contractor's perspective, it was a really detail-oriented process that required them to be nimble on site and modify elements as needed. It's also important to keep in mind the perspective of regulators like building inspectors who won't be familiar with this type of approach. There were some concerns from the building inspector about how prefab panels are connected to the existing building. They saw it as high risk, and they may ask for more documentation, which is, of course, additional effort and cost. And of course, it's important to consider the tenants. They were living through a pretty major retrofit, and they were accommodating and flexible, but keeping them informed about progress and any potential delays is also crucial. And finally, consider if this is an appropriate application for prefab, particularly evaluating the building size and shape. From the building owner's perspective, 575 Danforth is a relatively small multi-unit residential building in their portfolio, and they thought they would get better time efficiencies if they use prefab panels on a larger building. However, the shape of this building is relatively simple, and using prefab panels can be more complex on a different type of building geometry. Also, it's important to consider lead times. For Passive House certified windows and doors, the lead time was almost 5 months, and so they couldn't be integrated into the panels. And having a good understanding of how long each aspect of the panel will take to arrive and where it will be stored is important as well. Installing windows and cladding separately from the panels can sometimes undercut the efficiencies that are gained by using panels in the first place and increase the complexity of the installation. Overall, this project was a great learning experience for using prefab panels in a retrofit scenario. We are excited to monitor the building after construction is complete to see how the building is performing in both an energy performance and from an indoor environmental quality perspective. We'll be looking at how temperature, humidity, carbon dioxide, and particulate matter levels are changing. And in addition to IEQ monitoring, we'll be gathering feedback from tenants through a post-retrofit survey to assess their satisfaction with the new system. So thank you for your attention, and now I'll pass it on to ERA to share another exciting case study that's using prefab panels. Oh, I think you're on mute, Graeme.
Sorry. Good now? Okay, great. Sorry, I was very excited, said lots of nice things. And just kudos to TAF and to the team in TCH for taking on a project like this, where like the one that we're about to describe, there's just so much learning, and it takes a lot of leadership and a lot of risk to sort of do this. And you only get those lessons learned if that happens. So the rest of the industry can sort of say, okay, how do we optimize? So fantastic, and looking forward to seeing the finished results. So just sharing my screen now. Can everybody see? Okay, excellent. So we're a two-parter. I'm Graeme Stewart. This is my colleague, Santopinto. We're both principals with ERA and directors of the Tower Renewal Partnership. So I'm just going to do a setup. We were asked to sort of describe the context of our broader work, and then we'll do the deep dive to the panelization project under construction. So the focus of our work very specifically is large multi-res buildings like the ones you see here. This is an image of the suburbs of Toronto from 1965, and we talk about the housing crisis today. This is when they solved the housing crisis. They built a lot of housing really fast. Housing was abundant and cheap. This housing still forms the backbone of our rental stock throughout the country. So our mission really is to make sure that this housing stays for another generation, can last another 100 years. Let's not tear down housing to build new housing. Let's keep what we have and build more. So this is the focus of the Tower Renewal Partnership and a lot of our work. It's across Canada opportunity. This is a lot of data, but the navy blue is where these older apartments are. So it touches every community in Canada. And this, of course, was the way that governments sort of dealt with this. It was quite fashionable for about 30 years to tear it down. And we firmly believe that this is a political decision, not an economic or a thoughtful decision. So a lot of our work working with TAF and others has been to make sure that the proper due diligence is given to these buildings in terms of the full life cycle costing, carbon costing, and most importantly, working with residents and saying, what would you like to stay in your building and what improvements would you like to see? So Tower Renewal really has been looking at this holistically to say, let's work with what we have. Toronto Community Housing has been a big leader in this, and several years ago they sort of changed their policy to say any building 8-story and above, they would do that full life cycle analysis and not just tear things down out of principle. And that's led to a lot of amazing work in leadership and many studies leading to projects like the one that was just proposed here, looking at the panelization. When we look at these sites, it's both the eco retrofits and state of repair, but also opportunities for investments in social economic life and neighborhood transformation that comes along with these older high-rise districts. But focusing specifically on the buildings themselves, they're very large. Usually the buildings we're working on are 100+ units. They're aging in a relatively similar way, first generation windows, first generation HVAC systems, etc. Those are the best candidates for a comprehensive renewal because they've, everything needs to be replaced, and that sort of feeds into the life cycle costing. And as architects and engineers and designers, we also know you can build a green or net zero building that's terrible to live in, and that's what we don't want. So it's always starting with tenant comfort first and safety first, adding sprinklers, adding new fire alarm systems, etc. Putting it in better shape than when you found it, beyond just in addition as a co-benefit to carbon. And so through the Tower Renewal Partnership, we've worked with probably lots of you on this call to host symposium, to put white papers together, to sort of really push the notion of the importance of this in this sort of building sector. And thankfully, that's led to quite a lot of major programs. First provincially in Ontario, and then through the National Housing Strategy and the federal government, the Repair and Renewal Fund, the SEGA Fund, and other things that are bringing considerable dollars to deep retrofit. These are some of the different white papers that we've written. If anyone's interested, you can follow our website. And it really was with the National Housing Strategy, and we continue with this advocacy to make sure that in the drive for new supply, that we consider saving existing buildings as part of that accounting. If you've saved a unit for another 50 years, you haven't lost it. You don't have to rebuild it. So this is examples of some of the projects that we've touched, almost all exclusively affordable housing, and a real working with nonprofits and municipal housing companies with a real push to say, how do we make sure that we do deep retrofit and asset renewal and keep rents where, affordable, and that's critical. So the First case study is the Ken Sobel Tower, which some of you may be familiar with. A huge leadership from Hamilton City Housing. They had an end-of-life asset, this building here, that was either going to be sold or torn down. And they were looking for a life cycle analysis to say, what's the most prudent action? Is there any sense in actually keeping what they have and doing a retrofit? And thankfully, the numbers bore out. And more importantly, the community bore out. There was a lot of community leadership to say, don't tear down our social housing. Let's repair it and make it excellent. When we got involved in this project, it was empty. It was uninhabitable because of its state of repair. And there was a real leadership drive from Hamilton Housing to say, let's turn this into a best-in-class building. And at the time, the best-in-class was felt to be Passive House. So we were given the mission to turn this into a certified Passive House building. This is the building in 1967 when it was built as part of a centennial project, the sort of first and biggest social housing in the region. And this is it under construction and in the height of COVID. So we did a lot of field testing about how do you do a big construction project during a pandemic. A lot of the lessons that we learned in this project then filter into a lot of the other projects that we've done since, including 444 Logan, which we'll talk about next. But core values and part of the brief was basically every piece of this building was replaced other than the structure. All the distribution units are reconfigured to be fully accessible, new community spaces, and of course, reducing greenhouse gases by 94% and getting Passive House certified. In doing this, we were able to work with a lot of local trades to sort of build that knowledge. There was a lot of skepticism from the trades to say this was too ambitious, the air tightness targets were too tight, the R values were too big. And one of the biggest sort of kudos at the end of the project is that the trades and the contractor said, you know what, that wasn't so bad, let's do it again. One of those examples was this new product we worked on with Durock, which is a 6-inch extrusion of mineral wool for the entire facade. The reason we pushed mineral wool was because this was just after Grenfell and we wanted no flammability. That's really become the industry norm now, but at the time there was actually quite a bit of advocacy. And the contractor originally was saying, well, go with EPS, it's cheap, everyone knows how to do it. We really had to push for this solution, which led to new products being available on the market. Worked with Cascadia. These are Canadian-made Passive House windows. You guys probably expect them. And so there was a real sort of sense of local industry, Canadian industry, sort of taking on a wacky German standard. This is the building when it was complete. You know, fantastic views of the harbor. It's fully occupied now. It's a seniors building. The rents are deeply affordable, and it's really seen, you know, thankfully as a local landmark. And here's the Passive House certification that we, you know, worked tirelessly to achieve. So very, very happy with that. And the CEO of Hamilton Housing was emphatic that they achieved this, which really was fantastic as a North Star to keep everyone aligned when you hit those moments in the project where budget becomes an issue. How do you work around that in the smartest way possible without affecting performance? And this is an article about that Durock product that's now on the market for the overcladding with the mineral wool. And so I'm going to pause here and pass it to Yael. And this is where really at the end of every project, we sort of look at how do we then take those lessons learned and then impact the industry to grow and go to the next one. So on to you.
Fantastic. Thanks, Graeme. And so, you know, we wanted to show the Ken Sobel Tower because it is not a prefabricated project, but it's sort of an interesting A/B. This is a project we'll show next. Before we get into it, you know, as Graeme mentioned, we do a lot of learning on site, and I think we saw that as well with Natasha's excellent presentation there. You know, we learn so much on site. We actually help to push industry, but sometimes you get an opportunity to do that outside of a project. And if you'll hit the next slide, that's something we were able to do very recently with TAF's support. Thank you, TAF. And with our ongoing partnership with Wood Green, who is a nonprofit housing provider and does many other fantastic things here in the city. To actually bring together leaders from across North America, and I'm sure some of the folks on the call were actually here, to talk about prefabrication in the context of retrofit. Because what we knew after Ken Sobel was that it's great to do something like this in an unoccupied building, and it was fantastic to be able to achieve a lot of those targets. When you have an occupied building, we need to move quickly. We need to move with the minimum amount of disruption. We need to bring those costs down, I think, as Keith mentioned, over the long term. Prefabrication is going to do all those things, in addition to sort of the high performance targets we need to hit in retrofits, but we're not seeing the industry move in the retrofit sector, right? So we brought folks from, say the Rocky Mountain Institute, NYSERDA in the States, but also, of course, from across Canada, coast to coast. If you'll hit the next slide, from Pembina out west to Recover out east and others, and kind of said, where is the state of the market? What are you doing? How are you thinking about retrofits? And of course, our friends here at TAF did some fantastic presentations there on their pre-qualification roster. And we sort of wanted to take a state of the market. And I think, next slide, please. What we understood is that, things are progressing, but there are still very few great examples that people can point to and say, we did it here, here's what we learned. Don't be afraid, you can go ahead and do it too. So we'll speak now about a project that's just starting construction, 444 Logan Ave, and really is testing out this prefabrication approach. And unique opportunity. I mean, to do a do-over, a kind of A/B test. Ken Sobel and 444 Logan were actually the same footprint, same floor plate, designed by the same architect, and built in the same year, but in two different cities. Both kind of serendipitously now owned by social housing providers, housing seniors. So anyway, here we are working on the one on the right now, 444 Logan, and trying to actually do very similar things to what we did at Ken Sobel, but with an occupied building. Next slide, please. So Wood Green, again, really visionary clients, I think, are sort of the key piece that underlies all of the success of these early adopter projects. Said we want to renew our asset, we want to tackle some of our capital repair backlog, but this must be a net zero building at the end. But there is one key piece and one key directive from the client that we've sort of has driven everything from design through to implementation. That is, let's minimize disruption to our residents. So this is the building today, and in fact, uniquely, actually, with this building type, has already been overclad with a couple inches of insulation and some aluminum siding, as you can see here. So that's how it came to us. Nevertheless, was end of life, needed to be replaced, and the idea was like for like, or let's do something better. This is the project as it will be, we hope, in about a year from now when it concludes. And so we're about three or 4 months into construction now on a number of other things, but the panelization piece will be sort of the last 6 months. Next slide, please. So this slide is kind of like the ethos of the project, and if we circulate the PDF after, you'll be able to read all the small print. But basically what we said is over on the left, here are our key criteria, success criteria. This will be an innovative panelized retrofit of the envelope. We'll take an outside-in approach to modernizing and decarbonizing all of the mechanical systems, including the addition of air conditioning, similar to that TCH project we saw. We want to modernize the ventilation system, of course. We want to take a renewable approach, and you'll see some building integrated PV in the project. And most importantly, the tenants first approach. Everything we do guided by that sort of criteria. Funders on the project. So TAF here today, thank you, TAF. CMHC really as the main funder of the project through the Canada Greener Affordable Housing Fund, and Natural Resources Canada, who has really come to the table to say, let's actually help to support this project achieve some of its really innovative early market objectives around prefabrication, renewables, and net zero retrofit. Again, three main criteria here, really tackling a lot of state of repair issues, which is, as Graeme mentioned, kind of key to the success of these projects. We're doing all at once what might have happened like for like over a period of a decade, for example. The target here is 90+ GHG emission reduction, 90% plus, and of course, a full electrification. And there we see also, major reductions to the energy use, et cetera. So you know, while this is an envelope project, it's also equally a mechanical and electrical upgrade project as well. We'll talk a little bit more later in the deck here about how we've been mitigating disruption for tenants, but I will say, you know, critical to every trade being brought on site is actually a code of conduct around what that means. And to our CM partners, this is being executed under a 5B, and actually bringing on a CM who was actually ready on day one, understood the challenge of working with existing in people's homes, in and around people's homes, and actually had a real commitment to creating strong relationships with the tenants on the site. So I mentioned the outside-in approach. You know, these are some images from partners who are exploring things across North America, similarly, both prefabrication of envelopes and actually looking at outside-in approaches to distributions. And we'll show how we're doing that at Logan. Next slide. So we know, and I think Keith really, you outlined this well, we know that the panelization will reduce the duration of time on site and improve the QA/QC in the shop. But we, as expected, came to the market knowing there was almost nobody who was ready to go with a product that would work. Prefabrication is really advanced when it comes to new construction, but actually for a retrofit application where you have limited ability to tie on to the top of slab because you've already got a wall there, it's actually a very different product. And so we came to the market and found that there were several really fantastic bidders, and almost none of whom were completely ready. And so part of this project is really bringing those folks along. Quick note on the mechanical approach, which is really also kind of exciting, is that, you know, this is a you know, air source heat pump on the roof system, but we're actually drawing up hydronic risers on the outside of the building. So we're abandoning the radiators and suites, and actually in the gap that we have between the existing envelope and the new envelope, taking advantage to run all those distributions. And then the idea is at the very last moment, you're popping into the unit, and then you're coming in from the interior to kind of replace that terminal unit. So so that's been a real exciting approach, and certainly some exciting partners on the mechanical trade side who are ready to take it on. Next slide, please. The envelope approach here, and so we are working with Triumph, who locally are known for their curtain walls. And so they're actually coming in with a sort of aluminum framed prefabricated assembly that contains, you know, 6 inches of mineral wool, and your air barrier and all of your cladding, your windows, balcony doors, everything is coming in together. What we are doing in advance of that coming is actually we're putting up 3 inches of continuous site applied mineral wool insulation to actually bridge any gap between the existing facade and the new prefabricated facade. So what that does is that actually is critical for the continuity of the facade system and fire protection. And this is an image of what it's going to look like at grade. You know, what we're really excited about here is the sort of this and the Ken Sobel project. This is saying these are critical assets that we have. This is critical housing in our housing stock, and we're excited that it's the social sector who is leading and demonstrating what excellence can look like. Next slide, please. Back in 2020, now, we had an opportunity to work with CMHC, partnered with them through their research funding to actually test out, you know, after having done some retrofits with tenants in place, we knew it was not simple. And I'm sure anyone on the call who's done it understands that it's a very critical piece of success in a project like this. We were able to work with both construction partners and also tenant associations from across Canada to put together this field guide to retrofits in occupied buildings, looking at it from the perspective of tenants, contractors, and owners through all parts of the life cycle. What makes success? What are considerations? What are some tips and tricks? And thanks for Natalie for sharing the link. You'll find it in the link up in the chat there. How this hit the ground at Logan, and we're fairly excited about this, is when we did the field guide, we talked to people all over the world, really, who had done retrofits with tenants in place and said, what worked? And one thing we learned, actually from our colleagues at BC Housing, was if you can actually take away the risk on the owner from coordinating tenants, supporting all the support that tenants need when construction and invasive construction is happening in their building, and bring that over the contractor side, you're actually eliminating a lot of those frictions. You're saying to the contractor, you are empowered, but also responsible for customer care and for the well-being of tenants. And so what this contractor, and I will say, you know, this is something we say all the time, it really changes the tone of your interview with your CM. Because what happens is there might be folks who are very capable and can do all the technical bits, but they have no idea what you're talking about when you ask about this sort of customer care side. We actually required, we developed a bit of a scope of services for a tenant coordinator. And we said to the contractor, you're going to need to put this person on your team. They assist the site superintendent. They know everyone's name in the building. What are their needs? What are their mobility needs? Do they have a pet? Do they have a doctor's appointment? And you're actually helping to work with them to get into their site, into their building, in their unit when we need to. And kind of build and maintain those relationships. And I will say real credit to this contractor who's been fantastic, who's actually they went out to recruiters, said, we don't know what this is, but we're going to find that person. And they did. And Christine here over on the in the white shirt on the left, really, you know, when she stands up in front of the tenants like this, everyone applauds, right? And so it's a really fantastic news story. It's never easy to undergo construction in your building, especially in a kind of, you know, vulnerable seniors population, frankly. But there's a lot of goodwill and a lot of, I would say, like really mutual respect. So that's been fantastic. So just wrapping it up, I know we're at time. Completing the project in the end of 2026. We're well underway. We will hope to update you on how it goes. Last piece, and I guess this is 2 more slides and then we'll wrap. Through the support of NOCAN on this project, we're able to do a lot more than we'd be able to do just through the project itself. So next slide. We're actually able to look at this project and some others doing prefab retrofits to actually understand global best practice, to build some relationships and case studies with others doing similar kinds of projects and tackling similar challenges, and develop some kind of sector tools for other housing owners and multiple unit housing owners who may want to take on certain things. So what are the guides, kits, and tools they may need, as well as, you know, a really comprehensive post-occupancy evaluation being conducted in large part by TAF. So there it is. And, you know, last slide there was just really about the kind of connection of research and practice that's allowed us really to move between pushing markets and actually testing things in the field. Thanks so much.
Thank you all. Those were jam-packed presentations. I really appreciate that. I think we'll be sharing the slides afterwards so folks can dive in deeper, and this is a recording, so you can check back in. I'm going to launch into the question period because there are quite a few that have come through. Again, folks from the audience, if you have questions coming up in response to what we're talking about, just throw it in and we'll try to incorporate it. I'm going to start off with Graeme and Yael, considering this question from Betsy is speaking to the Logan project in particular. Were you able to estimate incremental costs, deep retrofit, and the difference prefab add-on subtracts for the Logan project?
That's a good question. The that I'm processing. So it's a yes and no. So we did look very seriously at field applied versus versus prefab. We didn't start this and say it's going to be a prefab project. There was data that led us there. But that was a push factor, definitely was then federal funding. Because when the idea that we were looking to do this and it was an option, suddenly when NRCan said there could be support to do as much learnings as we can, it nudged it in that direction. But the data that was used to sort of make that decision was that it was at least neutral on the schedule. And it's for all the reasons you're mentioning, Natasha, that some of the lessons learned is how is it better on the schedule than field applied? But because of the lead times, because of, you know, doing the windows integrated in the factory means that the windows have to be produced, et cetera, means that it's effectively neutral. And so let's do as much learnings as we can so we can come back with recommendations to make it better. But I think this really fits in the context of a pilot that is funded really for the purpose of learning and research. And hi, Betsy.
Betsy, do you have any follow-up questions?
No, I think that that's really positive. I mean, we're so early in this kind of idea, really, that if you can hit neutral, this thing has legs. So it would be really great to see that come out in something public.
Yeah. And that'll be some of the post analysis and research, just to say what worked, what didn't work, like what are the recommendations, like how do we get ready. And as Yael mentioned about kind of building the plane as you're flying, there, thanks to Keith's work and others, there were actually quite a few bidders. I mean, we had 4 to 5 bidders. None of them were ready, right? So you had to sort of work with the one to say who's closest. And the winning bidder, the two of the things that really pushed it was, besides price and other things like that, was they produce the windows themselves. So there's an integrated supply chain there. You're not waiting on someone else, and it was all local. Where a lot of the other bidders required on international or cross-border, which is now a friction point, supply chains.
Thanks, Graeme. Building off of that, I selfishly want to ask a question that I had that came out of some conversations out in BC, where folks were, highlighting that there are a lot of folks that can do this work, but they need buyers. And I was just reflecting on, is this pre-qualification work, and maybe this is more of a question for Keith, is this pre-qualification work something that can enable the scaling of, big buyers wanting to invest in this?
Yeah, I mean that's the hope, right? That's really the driver for that initiative. So we knew pre-qualifying suppliers itself wasn't really going to change the market much, but bringing Toronto community housing in particular to the table, and demonstrating in the pre-qualification materials that there are projects that are coming both within Toronto community housing and other suppliers is really key. And I think Toronto Community Housing has 1,300 buildings, I think, in their portfolio, plus they've done at least 10 overcladding projects. And given the age of the buildings in their portfolio, they have a whole lot more in the pipeline. So that really, like, demonstrating that there is demand was key. And I think it's critical. And I think Toronto Community Housing for us, I think, is going to be probably they are our cornerstone partner. And I think it will continue to be when it comes to overcladding. And that project that Natasha spoke about was really their first foray into this kind of panelized retrofit, but it is not their last. They already have another project where we just completed closing the RFP now, and certainly more to come, I expect. I want to see some of these larger buildings that, like 444 Logan, I think that will be next.
I think also building off of that, considering so much of this audience of the big buyers is probably going to sit in the BC housing, the social housing oriented providers. It kind of connects to Stephen Lee's question about how are the other benefits that you guys did highlight quantified? Improved air quality, thermal comfort, tenant happiness, minimizing tenant disruption, all of those types of things. How is that quantified in the justification? Obviously, in the social housing sector, there's more of an impetus to prioritize these things. But if it goes beyond maybe the social housing world, are there ways that we're figuring out how to quantify those benefits? I know it's an eternal question, but wondered about your thoughts.
Natalie, I think, yeah, thank you. And thanks, Stephen, for the question. The first part of the question is yes. I mean, certainly we are tracking those things. At Ken Sobel, we had the opportunity to do kind of a longitudinal study that was really 360 through U of T, where they actually came in and spoke to tenants after in detail about what they liked, what they didn't like, what was a challenge, what was a learning curve, and with the operators, et cetera. So we have a lot of really good data from that, and surely that will be published soon, although I don't believe it's out yet. And of course, in addition to that, we do have the air quality monitoring and other kinds of indicators about comfort. And we will have that kind of more kind of hard data kind of information at Logan. So we think that's critical. There's so much to be learned from that experience. And there are simple things like you know, it may be very nice to have a triple glazed window, but for an elderly population, it may be actually sometimes a challenge to operate something that is so heavy or with a certain type of operation, let's say a twist rather than a push or something, right? So whatever, those kinds of learnings are critical, and we're taking them into account. But the co-benefits quantification piece is something that we hear asked from our nonprofit housing clients. I have yet to hear it asked outside of the nonprofit sector, for good reasons. I would just say that we don't typically see a case to do a deep energy retrofit that is energy-based only. We see a case when there is a big capital repair backlog that could also have energy benefits if you do it all at once. And that is a story and a set of, frankly, important co-benefits that is going to be universal across all sectors.
And then and interestingly with Logan, there's actually a lot of interest from the broader sector. So the non-social sector apartment owners we're doing knowledge sharing. And the interest there is, you know, building on the idea of asset renewal, is some of the most sticky things to do in an older building, you know, that's 50 years old, is riser replacements, you know, infrastructure replacements, things that are really messy and really difficult. And so this idea of how much can you run on the outside of the building? Could you run new water distribution on the outside of the building, you know, electrical distribution on the outside of the building? And so we're doing a version of that here, and looking at all the issues of how do you access those things, you know, pull away panels, so where the risers are, you can actually get to it if you need to, and that type of thing. But I think that's kind of promising, because if there's a way where owners can say, or private sector owners can say, I have to do millions of dollars of work that's really messy. If I encapsulate it, that means I can do it much faster, much easier, do it at once, and then you get, you know, other benefits. I will say though, these are very expensive projects. And it's really attractive to an owner who's going to keep this building indefinitely, where I think there's still a real challenge in the private sector. For most people, it's just chips you're trading for value. And, you know, there's some real things to solve there that we haven't solved yet.
Yeah, and just to add to that, I think on the expensive, you know, the cost of these projects, nearly all the projects that we're working on that are looking at overcladding, they're all being driven by need, yes, and those co-benefits, but also there are great funding programs that are in place, and the projects would not happen without those funding programs, for sure.
Thank you so much. Already, it is near the end of the hour. I have a question already dialed up, so this is a teaser for those who do have the time to ask. We're going to get into some other questions about scalability and practicality that have come up in the chat, but Alicia, I don't know if you want to wrap things up just at the end of the hour.
Yeah, thanks, Natalie. So once again, on behalf of Alberta Eco Trust and ENBIX, ZEBx and ZEBx and TAF, we'd like to thank ERA Architects for coming to this webinar today and sharing your case studies with us. I think it was very informative and is really going to help inform not just in Ontario, but what maybe we might be doing here in Alberta and BC as well. As mentioned, we will close out this webinar, and if you would like to stay on the call, you're welcome to do that. Our panelists have agreed to stay on for about another 15 to 20 minutes. So if you'd like to ask some additional questions, we will follow up post-webinar with the recording, as well as all those links that were shared in the chat. So we thank you again for joining us today, and all the best.
Thanks so much.